Good afternoon. I welcome you all for today's session on reinforcement learning, where one of our student scholar is Muskan has shared her problem statement, and an assignment was given to her for making the document related to all the reinforcement learning topics we have been covered till now on that particular case study. So, as we all know, that reinforcement learning is an advanced machine learning technique where we try to predict the model using experienced and feedback-based mechanism. So the algorithms and the methods follow property, Markov chain, Markov decision process, and Markov reward process, Bellman equation. That's what we have been discussing till now. And probably she has applied those concepts on her case study. Muskan, I hand it over to you for just briefing your problem statement in 1 or 2 minutes.
Yes, thank you, ma'am. So my problem statements consist of any Myntra, Amazon, it can be anything. So basically, this portal needs a real-time dynamic pricing system that can adapt to product prices based on the demand, competition from other websites selling the same product, and even based on the season peak. Like there might be some time where the few products have much more demand based on the season and based on the inventory that the how much stock is available for them. So using these factors, we need we need to adapt a system that uses reinforcement learning so that the company can maximize their long-term profit while also maintaining the customer satisfaction that they are getting the product on time, or maybe they are not buying from the same product from the other competitive websites.
Okay, the topics seems to be quite interesting, and it relates the what you call it your reinforcement learning subject. Yes, but I'll just like to share the playlist of my research paper writing series in the description box. You can go on that, and there is a video where it describes how to identify a problem statement for you know basically problem statement. Yes, this is very well defined. It's in 1 or maximum 3 lines. Yeah, and it describes what you are going planning to, and what the um, technique which you are going to use. That's the reinforcement learning MDP model. Okay, and what you are going to achieve, maximize. Now, generally, if you want to convert this problem statement into a research paper title or an aim, so that is not this much big if you might have observed some transaction papers or something like that. So I'll just suggest, now when you were explaining to me this topic, immediately I could suggest a problem statement if you want. I'll just share you these two recommendations, which I thought. Of course, this is just a recommendation. You can redefine this title. How does this seem? Adaptive dynamic pricing on e-commerce platforms. Because see, you have discussed on the Myntra platform. So you can write specifically Myntra platform here. And that's good because you have studied the Myntra platform, and probably every e-commerce platform's architecture is different. Maybe the optimization and as a machine learning technique behind it would also be different. So what you can do is that you can put your Myntra platform specifically if you want, or you can put an e-commerce platform, and while inside you can explain the entire concept through Myntra's predefined model, and you can compare Myntra model with all the other, like available Amazon or Blinkit or whatever. Majorly running e-commerce platforms, and you can have a comparative chart to show that why this particular model is better than what is already being used or existing. Second type of recommendation from my side is context aware reinforcement learning. Now, both are context aware, but you can change this I why I have framed this problem statement, because I totally believe that nowadays everything is context based. Okay, the same model cannot be successful for another data set and may be very, very successful for some another data set. So it is all context aware. Okay, we cannot say that this is the best algorithm. One of the worst algorithm can be best for something else. Fine. So that's why I have mentioned context, because this context might sound just two words, but there's a lot more to be done still in the field of AI and machine learning as far as context aware system is concerned. I can share my one of the research papers published a decade back on, how to identify moods from particular videos based on context. Okay, so sometimes we ourselves, whatever is our perspective and what is our objective when we are looking in a video, okay, that may be much different than what is another's perspective and objective. So that is again context based. ओके एक कहावत है कि जो हमें देखना है वही हमें दिखता है. Somebody can say that the glass is half filled, the another person can say it's half empty. So that's basically what we are trying to analyze here for the dynamic pricing and optimizing sales on fashion e-commerce platform. So I just tried to make it more using this word, because we all know that Myntra is more famous for uh, fashion providing e-commerce sales platform. So, how did you like these problem statements, Muskan, and the other people on the panel?
Yes, ma'am, the first one is quite well arranged,
Well
and
arranged,
the
because
word,
it gives
yes,
Mintras
ma'am.
also over here. Yeah. Okay. Yes. So, likewise, you can frame your problem statement. There is also a video in that playlist, how to use AI tool to identify problem statements. So while listening to you, hardly in say fraction of seconds, I could frame two problem statements using AI tool, because right now I cannot immediately use my brain. So AI gives us very good recommendations. Of course, after that you finalized it, because it's your problem statement on which you might have spent so much time on framing this document. So would you like to add more on the upcoming contents? Then we will shift to Apurva's document.
Sorry, ma'am, could you please repeat?
Do you want to add up the contents which are following this? And then we will shift to Apurva's document then.
Yes, ma'am. So basically, here we have set of states in reinforcement learning. The basic five fundamental components are listed. So one of them is set of states. Set of states in our example could be defined as any state the product is in. Like for example, the current price of the product determines one of the state. Next could be at what price it was sold, even if it was after giving discount. So that could be another state. So such many states can be listed, and it all the possible situations that the system can be known as the set of states. Next, we have the set of actions. So for set of actions, we will be having all the decisions that we will make for the better sale of the products. Like for example, it might be like decreasing the price or increasing the price by some amount, or maybe offering some percentage of discount to a specific group of people because they might buy a lot of stuff recently. So these all can be the actions that might affect the decision of the sale of the product. So this will be the set of actions. Next, we will have the transition probability function. So what does this mean is basically the movement of the movement from one state to the another given state, which is the current state, will be known as the transition probability. So like for example, a product was initially priced as 1,000 rupees, and after taking some action, that is giving a discount of say 50%, it was priced at 500 rupees. So that will be the probability transition of a state. Next, we will have the reward function. So, reward function can be related to as that the product is being sold. So, we will get the profit from it. So, that will be the reward function for us after applying some actions to it. Next will be the discount factor. The discount factor is basically the importance of the future rewards. It focuses on the long term profit. Like, for example, if today's sale was very less as compared to the previous ones, we know what actions to be taken and what the discount factor will be based on that. Next, we have value functions and policies. So, for this, it basically predicts the long term benefits of being in a certain state. So, like for example, if stock is very low and the demand is high, we know that we need to raise the price because there are no competitors with us who have the stock. So, the people would obviously come to us to buy, and as the stock is low, the people will also buy it uh, in higher price, so we can maximize our profit, and we would also get long term benefit from it. The learning algorithms that we can uses q learning, because the price changes by testing them and recording the rewards. So whenever we get the maximum rewards, we can optimize that solution only and apply it for the future inferences. So that could be a learning algorithm. Next will be probability concepts. So, probability concepts are basically the concepts, the probability that whether it can be whether the product will be bought by any customer or they may not buy it. So, this is the 0 1 situation that determines the probability. So in our case, the as the probability cannot be negative, so the demand of the product being buy and product being buy should increase. So it will be always greater than zero. So we can find such many probabilities, and then on basis of that we can find an conclusion. Next we have the MPF, PMF, that is probability mass function. So which gives the probability of discrete outcomes. Discrete meaning which are not continuous. So either the demand will be high, medium, or low. So according to that, we can determine the probability and then focus on our sales. That what needs to be done when the probability is high, medium, or low. Next, we have the probability density function. For this is for the continuous values, like the specific amount that per order may be continuous, like ranging from pricing 200 or 5,000. So it basically tells us which price range are most likely to be sold. The product is most likely to be sold in. So we can determine the price value from PDF. Next is the cumulative distribution function. In cumulative distribution function, a variable is less than or equal to the value. So the probability will generally tell whether the customer will buy at a particular threshold or not. So we if you want the sale to be maximum, we cannot go higher than a particular value threshold set to us. So that will help in the increase of the sales. Next, we have the expectations. We expect from our system to give us the most reliable solution that will help us in increasing the sale for the current state or as well as for the future, that is long term states. So if the prices are given and the profits are given to us with the probabilities, we can examine what will be our expectations and what will be the average outcome. So this is basically what I have inferred from my model.
Yes, very good. Um, this is the model, okay, visual representation. Yes, it was quite,
Yes, ma'am.
yeah. Just the session is about to end. Before that, I have a question. Which AI tool did you use? Claude, ChatGPT, or what to create
Ma'am,
this?
ma'am, for the visual representation, I use ChatGPT.
Okay.
And for the meaning that is written in short,
Okay.
like one line meaning of every state actions and all those things, for that also I use ChatGPT.
Okay. Good. Fine. So maybe in the next lecture, I can tell you how to frame the same contents, okay, in a IEEE format for your research paper with the two titles I had given. So you selected the first one, and if you are interested, we can do that as a session, or you can go through my lecture series. Okay, and also I will be sharing the notes in the description box with a handbook so that those all who are attending the session, okay, may understand that how this document relates. Okay, so probably you might have shared the format of the handbook. Yes, Muskan, so that you got the same things in the same format. Am I right or wrong?
Yes, ma'am, I shared the headings, like
Yeah.
what all I need.
Yeah, so that was from our handbook. Okay, so I'll share the handbook in the description box, and similarly, all students can also prepare that on their case study so that they proceed with their research paper. So this is how you're going to go with your project topics also. Here we are considering reinforcement learning. For other topics or for other methodologies which you are going to use, the process will be the same. So, okay, so thank you very much, Muskan, for this briefing and for others for patience listening. So I end this particular session. This is Ayesha Butalia signing off.